The exact threshold for home automation equipment installation by non-licensed electrical contractors can vary depending on local regulations and specific tasks involved. However, the following general guidelines apply. As a basic rule, non-licensed individuals are typically prohibited from modifying or working on electrical wiring, including for low-voltage home automation devices. There are, however, some exceptions. Low-voltage switching devices may be installed in some jurisdictions by non-licensed individuals, provided that firstly, the modules are factory-assembled and pre-wired. Secondly, they do not require any modifications to electrical wiring or connections. And thirdly, they are installed in accordance with manufacturer instructions and local codes. Non-licensed individuals may be allowed to add or modify convenience outlets as long as firstly, the outlets are properly grounded and protected by a circuit breaker or fuse. Secondly, they do not require running new wiring through walls or ceilings. And thirdly, they are installed in accordance with local electrical codes. Some activities are strictly prohibited. Non-licensed individuals should never attempt to modify or extend existing electrical wiring, install or connect electrical panels, transformers, or junction boxes, powered devices directly from the service panel, or perform any work that requires knowledge of electrical codes and safety regulations. It is highly recommended that you obtain a proper license by completing the electrical contractors test. This will legitimize your business and protect you from liability. Familiarize yourself with local electrical codes and consult with the appropriate authorities to ensure your work complies. Keep detailed records of all installations, including materials used, inspections, and warranties. For more complex projects, consider partnering with a licensed electrician to ensure compliance and safety. This ensures the installations meet the standards set by organizations like the National Electrical Code, or NEC. The NEC provides comprehensive guidelines for electrical installations to safeguard people and property from hazards arising from the use of electricity. These guidelines cover various aspects, including wiring methods, overcurrent protection, grounding, and equipment installation. For example, NEC Section 310.15 details the allowable ampacity of conductors, ensuring that wires are not overloaded and can safely carry the intended current. Overcurrent protection, as outlined in NEC Article 240, is crucial to prevent fires and equipment damage from excessive current flow. This involves using circuit breakers or fuses that automatically interrupt the circuit when the current exceeds a safe level. Grounding, covered in NEC Article 250, is essential for providing a low impedance path for fault current to return to the source, thereby minimizing the risk of electric shock. Grounding systems must be properly installed and maintained to ensure their effectiveness. Equipment installation must adhere to NEC Article 110, which covers general requirements for electrical installations, including proper clearances, access, and working space around electrical equipment. This ensures that equipment can be safely operated and maintained. Specific equipment, such as transformers and switchgear, have additional requirements outlined in their respective articles. For example, transformers must be installed with adequate ventilation and protection against overcurrent and over-temperature conditions. Switchgear must be installed in a location that is readily accessible and protected from physical damage. Compliance with the NEC is typically enforced by local electrical inspectors, who review plans and inspect installations to ensure they meet the code requirements. Failure to comply with the NEC can result in fines, project delays, and potential legal liability. In addition to the NEC, other relevant standards and regulations may apply to electrical installations. These can include state and local electrical codes, as well as standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. The IEE develops standards for electrical engineering, including power systems, telecommunications, and electronics. The NFPA develops codes and standards related to fire safety, including the National Electrical Code. Understanding and complying with these standards and regulations is essential for ensuring the safety and reliability of electrical installations. Furthermore, specific scenarios dictate particular attention to detail and adherence to guidelines. For instance, when installing a flush-mounted X-10 dimmer module into an existing 120-volt circuit, it's imperative to verify the module's compatibility with the circuit's load requirements. Overloading the dimmer module can lead to overheating and potential fire hazards. Ensure the dimmer is rated for the appropriate wattage and that the wiring connections are secured to prevent loose connections and arcing. When powering a controller beside the service panel, proper grounding is paramount. The controller should be connected to a dedicated circuit with appropriate overcurrent protection. Avoid tapping into existing circuits that may already be heavily loaded. Use a properly sized grounding conductor to connect the controller to the grounding electrode system. In scenarios involving smart home equipment installation, meticulous attention to detail is crucial. Firstly, understanding the voltage requirements is paramount. Low voltage systems, typically operating at 24 volts alternating current or less, demand different handling than standard 120 volts or 240 volts alternating current circuits. Secondly, ensure that all wiring and connections comply with the National Electrical Code, or NEC, and local electrical codes. Thirdly, proper grounding is essential to prevent electrical shocks and equipment damage. Fourthly, use appropriate connectors and wiring methods for the specific application. Fifthly, label all wiring and connections clearly for future maintenance and troubleshooting. When working with low voltage systems, it's essential to differentiate between Class 1, Class 2, and Class 3 circuits, as defined by the NEC. Class 1 circuits operate at higher voltage and power levels and require more stringent wiring methods and overcurrent protection. Class 2 and Class 3 circuits operate at lower voltage and power levels and are generally considered safer. However, even with low voltage systems, it's crucial to follow proper wiring practices to prevent short circuits and other hazards. When installing smart home devices, it's important to consider the overall system design and ensure that all components are compatible. Avoid mixing and matching components from different manufacturers without verifying compatibility. Use a properly sized power supply for all low voltage devices. Overloading the power supply can cause overheating and premature failure. When running low voltage wiring, keep it separate from high voltage wiring to prevent interference and potential hazards. Use dedicated conduits or raceways to separate the wiring. In addition to wiring and connections, proper installation of smart home devices also involves configuring the software and network settings. Ensure that all devices are properly configured and that the network is secure. Use strong passwords and enable encryption to protect the system from unauthorized access. Regularly update the firmware and software on all devices to patch security vulnerabilities. When troubleshooting smart home systems, it's essential to have a systematic approach. Start by checking the power supply and wiring connections. Use a multimeter to verify the voltage and current levels. Check the network connections and ensure that all devices are properly connected to the network. Consult the manufacturer's documentation for troubleshooting tips. When replacing components in a smart home system, use only approved replacement parts. Using non-approved parts can void the warranty and potentially damage the system. When making any changes to the electrical system, always disconnect the power before starting work. Use appropriate personal protective equipment such as gloves and safety glasses. If you are not comfortable working with electricity, consult a qualified electrician. It's essential to stay up to date on the latest electrical codes and standards. The NEC is updated every 3 years, and it's important to be aware of any changes that may affect your work. Attend continuing education courses to stay informed about new technologies and best practices. Consider joining a professional organization, such as the International Association of Electrical Inspectors, or IE, to network with other professionals and stay up to date on the latest industry trends. When installing smart home systems in existing buildings, it's important to be aware of any potential hazards such as asbestos or lead paint. Take appropriate precautions to protect yourself and others from exposure to these hazards. When working in confined spaces such as attics or crawl spaces, ensure that there is adequate ventilation. Use appropriate respiratory protection if necessary. When working on ladders, follow proper ladder safety procedures. Use a ladder that is tall enough to reach the work area without overreaching. Set the ladder on a firm, level surface. Maintain 3 points of contact with the ladder at all times. When working outdoors, be aware of the weather conditions. Avoid working in wet or windy conditions. Use appropriate personal protective equipment, such as sunscreen and insect repellent. When working near energized equipment, use appropriate lockout/tagout procedures to prevent accidental energization. Verify that the equipment is de-energized before starting work. Use insulated tools and equipment. When disposing of electrical waste, follow proper disposal procedures. Recycle electronic waste whenever possible. Dispose of hazardous waste, such as batteries and fluorescent lamps, in accordance with local regulations. Remember, electrical work can be dangerous. Always follow safe work practices and consult a qualified electrician if you have any questions or concerns. Regarding specific equipment, consider the following points. For smart thermostats, ensure compatibility with the existing heating and cooling system. Install the thermostat in a location that is representative of the average temperature in the room. Calibrate the thermostat to ensure accurate temperature readings. For smart lighting systems, use energy-efficient light bulbs. Consider using dimmers to reduce energy consumption and extend bulb life. Program the lighting system to turn lights off automatically when they are not needed. For smart security systems, install cameras in strategic locations to monitor the property. Use motion sensors to detect unauthorized activity. Configure the system to send alerts to your smartphone or email address. For smart irrigation systems, use weather data to adjust watering schedules. Avoid overwatering plants. Conserve water by using drip irrigation or soaker hoses. Furthermore, consider the impact of smart home systems on energy consumption. While smart home devices can help to reduce energy consumption, they can also increase energy consumption if they are not properly configured. Use energy monitoring tools to track energy consumption and identify areas where you can save energy. Program devices to turn off automatically when they are not in use. Consider using renewable energy sources, such as solar panels, to power smart home devices. Smart home technology is constantly evolving. Stay up to date on the latest trends and technologies. Attend industry conferences and trade shows to learn about new products and services. Read industry publications and online resources to stay informed about the latest developments. Smart home systems can improve comfort, convenience, and security. By following safe work practices and consulting a qualified electrician, you can enjoy the benefits of smart home technology without compromising safety. Always prioritize safety when working with electricity. Electrical work can be dangerous, and it's important to take precautions to protect yourself and others from harm. Remember, proper planning and preparation are essential for a successful smart home installation. Take the time to plan the project carefully and gather all the necessary materials and tools before starting work. Following these guidelines will help ensure a safe and successful smart home installation. Finally, documentation is key. Maintain detailed records of all work performed, including wiring diagrams, equipment specifications, and test results. This documentation will be invaluable for future maintenance and troubleshooting. Keep copies of all permits and approvals. Provide the homeowner with a copy of the documentation and train them on how to operate the system. By following these guidelines, you can ensure that smart home installations are performed safely and in compliance with applicable codes and regulations.